Hey everybody, welcome back. So what we're going to do now is we're going to look at how a single converging or positive lens can form a virtual image and look at a use of that, an application of that. So to form a virtual image, what has to be true is that the object has to be in between the front focal point and the lens. Okay, so you can see in this ray trace diagram, the blue object arrow is right here. It's in between this F1 and the lens. So if that's the case and you do the standard ray trace, look, here's ray 1. This is the one we always would draw, parallel to the optic axis from the tip of the object arrow. That's got to go through the rear or back focal point. The other ray that we draw is one that goes straight through the center of the lens from that object point. If you look at rays 1 and 2, see they're diverging now. They're getting farther apart as they travel from the lens. So what we do is from the center of the lens where we drew that refraction, that bending, we just draw these rays that leave the lens straight back. See? Dash, 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 dash. Just keep it going. Same with ray 2. Draw this one straight back. Dash, 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 dash. And those two rays appear to come from right here, that point. That is the tip of the virtual image arrow. So once you have that tip located, again, you just start at the optic axis and we draw up to the tip. That's our image arrow. Now, just like in the previous diagram, this picture shows a third ray being drawn. It's not necessary, but this purple ray is drawn, I'll just describe it. It's drawn as if it came from that the front focal point. And that one will end up going horizontal. And if you trace that one backwards, it also will intersect right here. But don't even worry about the purple ray. Just focus on, again, no pun intended. I know, I use that one a lot when talking about lenses and light. But anyway, just look at ray 1 and 2. That's all you need. So here's our image. And again, it's virtual because it's formed with diverging rays. And you see it right there. Okay, now, if we were going to label some distances or some quantities, I should say, that would be the focal length of the positive lens from lens to that back focal point. There's the object distance from the object to the center of the lens. That would be a positive p if we obeyed the plus-minus convention. The image distance, always measured from the lens to the image location. Now, if we were worrying about the plus and minus signs, like we were using a formula where we have to pay attention to those signs, that is actually a negative image distance because it's to the left. So in those formulas, the negative image distance means the image is on the left side of the lens. Okay, and then that would be the object height right there, the height of that blue arrow. That would be positive if we obey the plus-minus convention. And then the image height would be right there. And that H prime would also be positive if we were going to use those formulas. Now, an application of this is the simple magnifier. So like a magnifying glass, that's a simple magnifier. It's a single positive lens that gives you a magnified or bigger virtual image, bigger than the object. Or if you think of, you guys have probably looked in a microscope before, the eyepiece lens is a simple magnifier. It's acting like a magnifying glass. So, I'm including the simple magnifier as another application of a single positive lens. Did I say simple magnifier or single magnifier? I meant to say simple if I said single. But we talked about the simple camera and the simple projector as applications of a positive lens. Well, here's a third application, a simple magnifier. So remember, simple magnifier is a positive lens, but you put the object inside the focal point. And by inside the focal point, we mean between the front focal point and the lens. And here's the ray trace. And to see this virtual image, your eye or a camera lens, right, would have to catch some of these diverging rays. So your eye is going to be over here, catching those rays. And if you catch those rays, what you're going to see is this virtual larger than the object, non-inverted, or some people would say upright, non-inverted image. It's not upside down compared to the object, and it's on the same side of the lens as the object. And that's what you would see. Now, it turns out, because we're talking about how big this virtual image looks to you, because it's not a real image, when we ask how big does it look, it turns out that that is a function not just of the height of this arrow, but also how close is this arrow formed to the lens. Because if you think about it, right, imagine holding a pencil up in your hand and you're looking at the pencil, yes? And you say, okay, how big does that pencil look? And you say, okay, all right, it looks about that big, right? Now start moving that pencil farther from your eye. I think you'll agree that the pencil looks smaller and smaller, right? As you move that pencil farther and farther away. So when we're talking about the magnification or how big something looks to your eye in the simple magnifier, we don't just worry about the height. We also, of the arrow, we also worry about how close is the arrow formed to the lens. See, in something like the simple projector or simple camera, that they form a real image, because they form a real image, you can actually measure the height of the image on the screen. So you can talk about the magnification as just being a ratio of the heights. But for the magnifier, where it's a virtual image formed, you incorporate not just the height, but also the distance, the image distance. Now, formally, if you just look at the height ratio, that's called lateral magnification. And if you're looking at both height and distance, you form what's called an angular magnification. And there is a difference between those two. We're not going to worry about the nuances, the differences, the official differences between those two. But I say this because it turns out that for a healthy eye, the closest that you can get something to your eye without it being difficult to focus on, that's called the near point of the eye. And we'll talk more about the near point in a subsequent video when we talk about how to correct some common vision problems. But the near point for a healthy eye is usually taken to be 25 centimeters. Now you can try this on your own. Go back to holding that pencil in front of your eye. Ask yourself, how close can I get that pencil? Because the closer I'm getting it, right, the bigger it looks. So how close can I get it without it being hard to focus on, without it being blurry? And it's usually taken to be about 25 centimeters. So if you form this virtual image with your simple magnifier so that it's about 25 centimeters from the lens, that's usually taken to be the best place to form the image, because that'll give you the biggest possible image, but it won't be blurry. It won't be hard to focus on. So if you want your simple magnifier to do the best job it can in getting the biggest image without it being hard to focus on, you try to aim for 25 centimeters. Okay, so you would adjust the object distance so that the image distance is 25 centimeters. Okay. All right, we'll talk more about that when we do our thin lens lab. Okay. I'll mention that again. Okay. I think, I want to go to that applet just to show you again how you can make the applet do this virtual image formation. I think my next slide is negative lenses. Yeah. So that's all I wanted to show you here. Is how the simple magnifier ray trace works. But let me go to the applet. And again, I invite you guys on a piece of paper, you try this virtual image formation, this ray trace. So again, on the piece of paper, all you need to do, look, we can do it real quick right here, is, I think I can do it real quick. Yes, look, draw a line. That's your optic axis. Put a generic positive lens shape. You've got 2 points. Just draw them just like that. Okay, those are your 2 focal points. Now, put the object arrow inside the focal point. So now, if we do our ray trace, here comes the first one. By definition, right? That's got to go through this focal point. The second ray is going to go right through the middle of the lens. Oh, almost got it through the middle. Good enough. See, if you do a fairly careful job, these 2 rays are diverging. So trace them back. And they should appear to meet right there somewhere. Boom, 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 boom. That's supposed to be straight. There's your image right there. Okay? So again, if you do a fairly careful job with your rays, they'll do what they're supposed to do. And you'll be able to form the image that's the correct image. Okay, so now let me go to the applet again. And again, you can find this on our course page. So you want positive lens. Oh my, come on. Oh yes, it was quicker this time. I guess since it's loaded at once already. So let me move my capture screen over. So all you need to do is grab the object arrow and again, move it inside that front focal point. And there you go. There, that purple arrow is the virtual image. Now you can see that, look, as I get this closer to the lens, the object, the virtual image gets formed closer to the lens and it's not as big. And as I move the object farther from the lens, the object arrow gets bigger but farther away. Now, again, bigger doesn't necessarily mean better magnification, more magnification, because you also, again, have to factor in how close is this purple arrow formed from the lens. So when you're looking at the magnifier, it's that angular magnification that's important. There are formulas developed that define angular magnification. I'm just not going to focus on them. It's not necessary. I may mention, we may discuss those formulas in lab. Actually, I'm going to talk briefly about, in another video, dealing with this part about a microscope and telescope. And I'll show you those formulas in that video. Okay? Okay. All right, that's it. I'll see you in the next video where we look at how a negative lens can form a virtual image. Okay, bye.